Hey guys, so today we'll be looking at Leetcode 611 valid triangle number. So given a integer or enums, return the number of triplets that can be chosen from the array such that can make triangle if we take them as side lengths of a triangle. Okay, so we'll be given an input array nums and we need to choose 3 elements from it such that they can make a triangle, and we need to return the number of triplets that we can choose. Okay, so one thing I would like to let you know about triangle is that if we say have a triangle of side A, B and C, so the sum of two sides which should always be greater than the third side. Okay, so this is like the validation check that we're going to do to get to our answer. Okay, so this is the requirement to form a triangle. Okay, length of any two sides should always be greater than the third side. Okay, yeah, you can even visualize it, right? Let's say this is of length 1, this is of length 1, and let's say a third side is of length 5. Okay, so you can see, right, it does not form a triangle. Okay, so yeah, this is the condition that we are going to check. Okay, so initially I thought the constraints seemed a little less. Okay, so I thought we could do a DP and we can figure out all the possible combinations of 3 triplets and we can just return it. Okay, so you can imagine, right, our sample space is about 1000 and we need to choose any 3 elements. Okay, so it will fetch us a, it will be a very large number and it will give us a TLE. Okay, so we need to find a better approach to this. Okay, so this is the validation check. Okay, we are going to keep this in mind. Okay, so you can see, right, we need 2 elements and the sum should always be greater than the third element. Okay, so what we can do is we can fix our 2 elements. Okay, let's say this is my first element, this is my second element, and I can just check for my third element if it satisfies the condition. Okay, so here 4 and it is greater than 3. Yep, it does. So 4 is not greater than 4, right? So it does not satisfy the condition. So similarly we can, so this was our first element, this was our second, and this was our third. It gives us 1 triplet. Similarly, if we choose our second element to be this, then this gives us another triplet. Okay, so that is how we can go about this problem. Okay, so you can see, right, what we would need 2 pointers, and we would, let's say I fix these 2, then I would go about my input and I can find my third element. Okay, so it will be n square and another n for searching a third element, so it will be n cube. Okay, so we can optimize this, right? So if we sort this array, okay, in this case it is already sorted. Okay, but it is already sorted, then we can just fix our 2 elements and then we can search for the third element in this part. Okay, so this will be a little optimization, but in the worst case, of course, let's say I have a array of 1000 and I choose the first 2 elements, then I still have to search this entire sample space, right? So it will still be n cube. Okay, so we would need a better way to do it. Okay, so we can use, okay, so if my array is sorted, okay, if I, this is my, let me move this a little downwards. Yep. So if I have my two elements fixed, then I just need to search in this space, right? So what I can do is, so what is the condition that we had? A plus b should be greater than c. Okay, so we can determine the maximum value that c can have. Okay, in this, let's say it was 2, so it is 4. Okay, so c cannot take a value which is greater than or equal to 4. Okay, so that is what we are going to do. So you can see, right, this, let's say this is our index, these are my indexes, and the index of element 4 is 3. Okay, so what I can do is, the element which are less than 4 are in this side of the array. Okay, since our array is sorted, so I can say whatever element are previous to it, these will all satisfy the condition. Okay, so if my index of this element was 4, okay, c is 4, okay, and my index is 3. Okay, so I can say, right, 3 elements, these are the 3 elements. Let me take a different color. Okay, so these are the 3 elements which are less than 4. Okay, and in that I would need to exclude the elements which I have already selected. Okay, so what I can do is, I can subtract the elements before my second element. Okay, so let's say if my array was 1 2 3 4 5 6, okay, let's say if I was at these two, okay, so I would just eliminate this entire sample space. Why? Because I would already have got the combination, right? Let's say if this was making a triangle, I'm not checking the condition right now, but let's say if these 3 elements are my triplets, okay, then I would already have got it when I choose these 2 elements. Okay, you're getting the point, right? So if I had choose these 2 elements, then I would have found my this element, and the triplet which was possible, I would already have counted it against my answer. Okay, so that is why what I'm going to do is, if I was at, okay, if these are the 2 elements which I'm going to take, okay, then I can just eliminate this entire sample space. Okay, so let's say, okay, let me explain you with this example only. Okay, so if I have this and this as my second element, my 2 elements, okay, then my A is 2, B is 2, their sum is 4. Okay, so I cannot have an element which is greater than 4. Okay, so how many elements do I have which are less than 4? I have 3 elements. Okay, I have 3 elements. Less than C. Okay, let me call them as C. Okay, let me take it as Y. Okay, so it will be 3. Okay, so, and which is the sample space that I'm eliminating? This. Okay, since I would already have gotten the combination for this part. Okay, so what I can do is, I can have my discard elements. how many are there. So if this was my first element, let's say this was I and this was j, so j is pointing at 1, and the total elements which I'm going to have is 2. Okay, so it is just j plus 1. Okay, so I can just subtract these two. So I can just subtract these two and it would give me 1. Okay, so this is the triplet which was possible. Okay, so I hope you got how I'm calculating. And so what we can do is, to find this element, to find the C, we can do a binary search on in this sample. Okay, so if my j was here, I would just search for my third element after that index. Okay, yeah, so this was the approach, and I'll quickly show you the code. Okay, so let me quickly walk you through the code, and things will be much more clear on how we are going to apply the binary search. Okay, so first of all, we are going to sort our input. Then I've taken an answer variable which I'm going to return, and I would need to fix two elements. Okay, so I would need a for loop to fix this element. Okay, so there's no way around it. I would need to have this loop, okay, which is of n square. Okay, and I would get my two elements fixed. Okay, and let me also explain you how this is going to work. Okay, so let me take the sample example as well only. So 2 3 4. Okay, so this will be my I, and I would fix my my j will move from here. Okay, so this is how the flow is going to be, and once my I comes over here, then j would always follow I. Okay, so that is how we are going to choose our two elements. Okay, for example, let's say I'm at this initial configuration, so my C would be what, 4. Okay, so I would need to search for the element which is 4. Okay, so what it is going to give, okay, let me also note down the indexes of this element. Okay, so I'm going to search for my C. Okay, and let me quickly explain you what lower bound and upper bound means. So lower bound will, if I'm searching in an array, it will always return me the address of the element which is equal to my search element. Okay, and if it is not present, then it will give me the address of the element which is just greater than my search element. Okay, so upper bound, it will always give me the address of the element which is greater than my search element. Okay, so this is the fundamentals of lower and upper. So I'm going to do a lower bound. Okay, why I'm doing the lower bound, let's say my search element was 4. It is 4, right? So I have to search for my fourth element. Okay, so if it is there, it will return. Okay, so what is my requirement? I want my C value should not be 4. Okay, so if I get the address of this element, which is, let's say my index was 3, so any element which is after that, it will also be not possible to include in my triplet, and the only possible numbers which are less than my search element will be this, right? So if my index was 3, then this will always give me the number of elements which are less than these elements. Okay, I'm searching for 4. I found my element 4 and its index is 3. Okay, its index is 3. Okay, so it will give me the number of elements which are less than 4. I hope you get this point. Okay, just try to run for a few examples and you'll get it. Okay, so I was searching for 4. I found my index to be 3. So I have 3 elements which will represent this part, which are less than my search element, which is 4. Okay, so also how I'm going to find the index of my search element. So lower bound. Okay, whatever I'm going to search, I'm just gonna subtract the beginning address. Okay, so whatever my array was beginning with, I'll just subtract that address with my search elements index and it will give me the index of that element. Okay, which is 3 over here. Okay, so I'm going to store it in X. Okay, so Y. What are the elements which I am going to disregard? Which is this, which is nothing but rj plus 1. Okay, so if my j was at 1, then how many elements do I need to discard? I need to discard 2. Okay, so that is why it is always going to be j plus 1 and it will be 2 over here, and I can simply just subtract my x and y to get the count of triplet. Okay, so what will be the complexity of this approach? So I would need the for loops for fixing my first 2 elements, right? So it will of course be n square, and for searching we are using binary search, and it will take a complexity of log n. Okay, so we optimized our solution from n cube to n square. Okay, so yeah, this was the approach and I hope I was able to make you guys clear, and I'll see you in the next video.